Today we're going to review functions. So this is section 6 of chapter 2, Introduction to Functions. So a couple of reminders. We spent a lot of time this week talking about domain and range. And so given any relation in x and y, we can say that y is a function of x if for each element in the domain, so each x, there is exactly one value of y in the range. So what does this mean? This means that no two ordered pairs can have the same x coordinate and different y coordinates, okay? So we can't have two values that would have, x equals, let's say 1, y is 3, x equals 1, y is -2. That would make it not a function. It would just be a relation. Okay, and then so let's take a look at how to tell the difference between functions and relations, both from a mapping, which is what these are, or from a set of ordered pairs, which we're going to create, or from a graph. Okay. So if we look at the first example A here, we see this mapping. We have the point 1 mapped to 3. We have 1 mapped to 4. We have 2 mapped to -1. And we have 3 mapped to -2. And so we have to decide if that's a function. Well, we said that no two ordered pairs may have the same first coordinate and different second coordinates. So since we have 1, 3 and 1, 4, that means that this is not a function. So okay, we can do the same thing for the other two. So I'm going to ask you to either pause the video or wait until the end of the video and go ahead and complete B and C for tomorrow. Okay, that's one option, is that we can look at the mapping, maybe create a set of ordered pairs and determine whether or not it's a function. And then the other option, which you probably remember from Algebra 1, is using the vertical line test. And so with the vertical line test, it states that if you were to imagine drawing a vertical line down through a graph, it would not be able to intersect in more than one point in order for it to be a function. So if we look at this first example here, if we were to draw, an imaginary vertical line, it would touch at least 2 points. So that would mean that this is not a function. If we look at the second one, however, this one would pass the vertical line test, and so we would say that this is a function. And just to clarify, this point here is not a point on the grid. It's actually a copier issue, so that you can kind of ignore, if you will. Okay, let's take a few moments to remind ourselves of function notation. So if we have some function, y equals 2 to the x, so of course this is a linear function. We've been spending a lot of time on linear functions. It may be written in function notation as f of x equals 2x, okay? And so we read that as f of x is equal to 2x. F is the name of the function, and typically f is, used. Sometimes you'll see p of x or g of x or h of x. X is an input value from the domain of the function, okay? So this is saying f of x, a function of x, or a function of the input values. F of x is the function value corresponding to a given value of x. So let's take a look at that in practice. Okay, so the first example here on the back says, evaluate f of x equals 2x at x equals 5. So basically you're finding the value of this function when x is 5. So what does that mean? That means wherever you see an x, you're going to plug in a 5. So this is like x is equal to 5, right? Okay, so we plug that in, and so f of 5 equals 10. That means the value of this function when x is 5 is 10. Okay, we could write this as an ordered pair because this represents f of 5 or f of x represents your y value, and the x is represented by the number here, 5. So we could write that as an ordered pair 5, 10. Okay. All right, so let's try one. Given the function defined by g of x equals 1/2 x minus 1, find the function values. Okay, so this is saying, what's the value of the function when x equals 0? So that means g of 0. Okay, and so what does that tell us? That tells us wherever we see x, we are going to plug in 0. Everything else stays the way it is. Okay, so we're just evaluating this function g when x equals 0. So what's 1/2 times 0? Well, anything times 0 is 0 minus 1. So the value of this function, the value of g of x at 0 is -1. Okay. Okay, we'll try one more. So let's take a look at the second one. We have g of 2. So we're going to evaluate the function when x equals 2. So that means wherever you see x, you're going to instead plug in a 2. Okay, so we multiply what's half of 2, and then 1 minus 1 is 0. So the value of the function at x equals 2 is 0. And again, you could express this as a coordinate point if you wanted. So you have the point 2, 0. That would be a point on the function g of x. Just like for the first example, you'd have 0, -1 would be a point on that function, or on that linear equation, if you will. Okay, I'd like you to either pause the video, or at the end of the video, you can go ahead and complete C and D. We're going to do one more where we evaluate, and we'll instead evaluate for something other than a number. Okay, so in this case, we're saying g of a. Same process. Wherever you see an x, you're going to instead plug in a. Okay, so this a is going to go in for x. So now g of a is equal to 4a minus 3. Okay, and you could still do this as a coordinate point. Your coordinate point would be a, comma, 4a minus 3. All right, I'd like you to, again, either pause the video or wait till the end and complete B and C, and we'll go through the answers tomorrow. Okay, the last thing I'd like to talk about is how to evaluate or find the value of the function given a graph. Okay, so at the bottom here, we have the graph. This is y equals h of x, so it's a function. It passes the vertical line test. Okay, and it asks you to find h of -1. So again, reminder, that means that this is saying x equals -1. Okay? So we go along the x-axis and we find -1, and we follow that up until it intersects the function. And so we have a value of h of x of 2. So h of -1 is equal to a positive 2. And then h of 2, same process. You're going to go over to 2 and then go up until you intersect the function. And so h of 2 is equal to positive 1. Okay, next one says, for what value of x is h of x equal to 3? Okay, so we're going to look for 3 on the h of x axis, or the y-axis, and we're going to go over until that touches the graph or the function, and then we'll go down and find the corresponding x value. Okay, so that means x equals -4. And you can kind of double check your work. So -4, h of -4 gives me a 3, and so that's correct. Okay, again, now that you're done watching the video, you can go ahead and complete letter D. So please complete all of the circled problems on the front and the back, and I will see you all tomorrow.